It's quite surreal, in fact, that this is my first total solar eclipse and I'm going to be looking at it on a computer screen. My name is Amir Caspi. I'm a solar physicist. I study the sun. Understanding the sun is important for understanding our place in the universe. On the day of the eclipse, August 21st, we're going to be looking for fast, dynamic motion in the solar corona, the outer atmosphere of the sun. What we're trying to study is why the solar corona is so hot. It's millions of degrees compared to only a few thousand degrees for the visible surface underneath. These planes require a lot of specialized expertise to fly and to operate the equipment.
So originally this aircraft was designed to be like a medium bomber. It was built back in the early 60s. Then this version that you see behind me, the WB-57, was fitted with larger wings, larger engines, and the ability to fly high. We're going to start briefing several hours prior to takeoff.
We have pilots and maintenance crew here that have dealt with these planes and these cameras for years.
The equipment operators are going to be the ones responsible for actually aiming the cameras and making sure that everything is captured.
That's something that takes hundreds of hours of training and experience.
We'll step to the aircraft pre-flight and do all of our final checks.
They are just cleared off. I'm going to call for taxi. Copy that. Going to ground NASA 926, taxi with Charlie. All right, here we go, dude. You ready? Yes, I am. Taxi lights on.
These WB-57 aircraft will be flying at an altitude of 50,000 feet. That's almost 10 miles up in the air.
And the reason we're trying to fly that high is to get above most of the atmosphere to get a clearer picture of the eclipse. Hands-on in the cockpit, I'm going to have those two monitors in front of me.
We're going to have two satellite feeds live from both of the aircraft.
One will have visible readout from the camera and the other one will have infrared.
They're going to be flying at approximately 450, 460 miles per hour. Now, the moon's shadow is going to be traveling at about 1,400 miles per hour.
When the eclipse begins, we'll turn into the path of totality, train the cameras on the sun.
So as the shadow overtakes the plane in the rear, for a brief moment, they'll both be in the shadow. That's what will allow us to stitch together the videos from both aircraft so that we can get a total of about 7.5 minutes of totality, compared to only 2.5 minutes for someone on the ground. They're going to get a better view than the astronauts will.
Yeah.
Because they'll get to see the eclipse.
It's a unique place to sit above all the clouds, above all the weather, gently see that curve of the Earth. I wish I could go myself, but it'll be good being with you on the ground and controlling these guys. And we'll be the next best thing. We'll be right there with them.
It's hard to say what happens once the jets touch down. Certainly, we will have data in our possession that nobody will ever have had before.